Selamat sejahtera, Doctor. I'm Lee Jarok with matrix number AN200204 from Group 11 of BNR 20903 Electronic Communication System, Section 3. My other group members are Fong Xinian, Li Jingwei, and Pang Weibin. And in this video, I will be presenting about our group project where we have built a modulation circuit. So in general, a modulation is a process by which some characteristics of a carrier is varied in accordance with a modulating wave. So the baseband signal is referred to as the modulating wave, and the result of the modulation process is referred to as the modulated wave. During this process, the baseband voice or digital signal modifies another higher frequency signal called as the carrier, which is usually a sine wave. Then a sine wave carrier can be modified by intelligence signal through amplitude modulation, frequency modulation, or phase modulation. In amplitude modulation, let the modulating signal be EMT equals to VM sine WMT, and the carrier signal be ECT equals to VC times sine omega CT. Then the modulator signal is expressed as ET equals to VC plus VM times sine omega T times sine omega CT, where M, known as the modulation index, is VM over VC. So in this project, we will discover two problem statements, which is how to build an amplitude modulator circuit, and the another one is what is the output from the circuit. The objectives of this project is to design and set up an amplitude modulator circuit using the applications like Proteus. Also, we want to simulate the circuit and take reading of its output signal pattern. The methodology in this project is, in this project, we will be using Proteus software to perform the building and simulation process. First, we will create a new project with a default template without using any PCB layout and firmware. In the software, we will insert the components required in building a modulation circuit, like below. So this is the circuit, the modulation circuit we have built with the selected component, which include 4 10 kilo ohm resistor, one 1N4001 diode, one microfarad capacitor, one milliamp Henry inductor, one AC voltage source with 5 volt amplitude and frequency of 10 kHz as the carrier signal, and another AC voltage source with 5 volt amplitude too, and a frequency of 500 Hz as the modulator signal. So this is the circuit we have built in the Proteus 8. As you can see here, our input of 2 AC source is connected, and the carrier signal is connected to the channel A, the modulator signal is connected to channel B, and our output signal, which is the modulated wave, is connected to channel D. So after we take the reading, we have found that the amplitude of our modulator signal is about 10 millivolt and it has a frequency of 500 hertz. That's because it is in phase with our modulator signal. So for knowledge, our modulation index is equals to 1 because both of our source of the carrier source and the modulating source has the same amplitude, which is 5 watt. So our project is an ideal modulation circuit, and whereby the greatest output will be produced at the receiver without any distortion. Hence, the maximum info signal amplitude is transmitted. The ideal modulation is hard to achieve, especially when the modulating signal amplitude varies randomly over a wide range due to its AC characteristic. Therefore, the signal will only produce 100% modulation at the peak of it. So, as we know, the formula of amplitude modulation is VAM equals to VC sine 2 pi FT plus VM over 2 cos 2 pi FC minus FM T minus VM over 2 cos 2 pi bracket FC plus FMT. So from our project, we will get the formula as below. And in the formula, we can know that 5 sine 2 pi t is the carrier and 2.5 cos 2 pi 9500 t is the lower sideband, while our upper sideband is about 2.5 cos 2 pi 10.5 kilo t. In conclusion, our project is successfully conducted by using the simulation software Proteus. So this is to say that we had obtained the characteristics of the output signal we predicted, which is a modulator wave with an amplitude of 10 millivolt and a frequency of 500 Hz when the simulation is carried out. Also, since this project used software to simulate the result, we don't need to undergo a try and error method by using the real materials to build the modulation circuit. Therefore, this project is environment friendly and it prevents the depletion of natural resources. So that's all from me. Thank you.